Okay, so final example looking here. Looking at my two denominators, they're both linear. So x plus 1, I don't have a greatest common factor that can come out. And 5x minus 6, I also don't have a greatest common factor that can come out. So I want to show, like number 3, I could take out a greatest common factor of 2b, and then the 2 was a common factor. Here, there's not anything that can come out, so I don't have a common factor. So I'm going to take the denominator of the other fraction and multiply it in as the number 1. So here is my fancy number 1. So this denominator went to this fraction, and then this denominator will go to this fraction. This works every time if you always want to take the other denominator and multiply it out by the numerator and the denominator to give me the number 1. So my two denominators here, I'm going to leave them factored. Never, ever, ever multiply the denominators out. So I'm going to switch the order on these so that they look identical. And then I'm going to multiply in here. So here I distributed 2. So I'll have 10x minus 12. I'm subtracting, and then I'm going to distribute a 4x. So I have 4x squared plus 4x. The number one mistake that people make in these problems is forgetting that this is a subtraction problem and only changing one of the signs, but I'm subtracting the entire numerator. So I'm going to rewrite this as an addition problem. These can get a little bit lengthy when you're writing all of your stuff out. It is recommended to take the time to write out all of your steps so that you don't miss a sign. So I'm subtracting this numerator, so I'm going to add the opposite. So that's going to be a negative 4x squared and then a negative 4x. And then I'm going to go through and combine like terms from those two numerators. So in order, we'll have a negative 4x squared. I have a positive 10x and a negative 4x. That would mean with a positive 6x and then a minus 12 all over x plus 1 times 5x minus 6. I do have a greatest common factor that can come out of this. I can take out a 2. I'm going to take out a negative 2 so that my leading coefficient will be positive. And I'll be left with 2x squared minus 3x plus 6. And then x plus 1 times 5x minus 6. If you remember when we did dividing, we said, when are we really ever going to use division? Division is helpful here to see if x plus 1 will go into 2x squared minus 3x plus 6. You can do a little division of this factor into this one, and then also the 5x minus 6 into this one. I will tell you that this does not factor. I'm looking for a product of positive 12 and a sum of negative 3, and it actually doesn't factor. So I can use either one of these with the GCF not taken out or the GCF taken out as my solution. Again, if you want to worry about the simplifying of the factors, we can focus on that tomorrow and just leave everything unfactored, and then we can come back and look at those tomorrow. Your homework for tonight, I have 12 problems that I would like for you to work on this worksheet. So we have some problems on the front. Watch for your common denominators. Those are always nice. And then on the back, you're going to stop at number 12. So we have not gotten to multiplication and division yet. We will get to those questions tomorrow. I put some additional practice problems on Canvas for you to view in addition to this video on Canvas. So feel free to check out other people's videos on adding and subtracting rationals.